Howdy, howdy. Right now what I'm going to do is go through a couple more transformations. Hopefully I'll be able to get through 2 of them this time since I've done a lot of the talking already. So again, we're going to identify the parent function, graph the parent function, talk about the transformations that are occurring, draw the transform graph, and then identify some of the important points. All right, so what type of function is this? It is exponential. All right, so just like in the first video, I'm going to go ahead and I'm going to do that in red. So I'm going to draw my exponential graph, which for 3 to the 2x, now this is a little bit different than what we usually have. We usually have the 2, so I'm going to have to think through this a little bit more. 3 to the 0 power is 1, 3 to the first power is 3, 3 to the second power is 9. So this is going to be a little bit steeper than what we usually have. All right, so from this point we can go ahead, oh, it didn't put my point on, did it? Okay, 3 to the negative 1 would be 1/3, and so then you got a basic idea of what the parent graph looks like, which should be something like this. I'm so much better doing this on real paper. Oh well, such is life. Now, as promised in class, I'm now going to require that you also put the asymptote down, and so the asymptote for any parent function for exponential should be at 0, 0, so you need to draw this dashed line, make sure it's dark and clear, at y equals 0. That's the asymptote. I put it dashed because that's not really part of the graph, but it is representing the fact that I can't go down below it. That is the limit. That's where it stops. All right, so now let's talk about the transformations. Okay, the parent function is y equals 3 to the x in this situation. So I've got 2 different things happening, right? There's a 2 that's being multiplied by the x, and then there's a minus 5. According to PEMDAS, the exponent stuff has to happen before the subtraction, or BEDMAS, the exponents have to happen before subtraction. So therefore, I'm going to talk about the 2 first, and then I'll talk about the 5. First off, is the 2 being applied directly to the x? Well, yes, it is. That's 2 times x. So anything applied directly to the x will be horizontal. Okay, now that we know that it's being applied directly to the x, we should also say step number 2 is that it's going to have the opposite effect. So instead of multiplying by 2, it's going to divide by 2, which is the same as multiply by 1/2. So it will be, when you half something, it gets smaller. So that will be a horizontal squish of 1/2. So there's the 2 done. Now we're going to look at the minus 5. So the minus 5 is not being done directly to the x. So our rule says if it's done directly to x, it's horizontal. Well, this is not directly done to x, therefore it is not horizontal. That means it's vertical. Now that means that from now on with this 5, I'm only thinking up and down. I can't do any side to side, no matter what it is. So now I got a minus 5. So I'm going to take the minus 5 and I'm going to say, okay, well that should mean a shift. Now because it's not being applied to x, it will be exactly what we expect it to be. So minus 5 should be moving in the negative direction. The negative direction for the vertical would be down. So vertical down 5. Okay, so last time I actually took the graph and I did one transformation for the whole graph and then I did the other one. This I'm going to do the other way. So I'm going to take the points and I'm going to squish it by 1/2. So right here, this is at 2, 9. So I'm going to half the x value, which will put me at 1, 9. And then I will move it down 1, 2, 3, 4, 5. So there's my first point. All right, here's the next one. It's at 1, 3. So I'm going to half the x value, which will be 1/2, 3. So it was at 1, 3. Now it's at 1/2, 3, and I'm going to move it down 1, 2, 3, 4, 5. All right. Here it is at 0, 1. I half the 0, which gives me 0, 0. So then I'm going, or sorry, 0, 1 still. So I'm going to move it down 5. 1, 2, 3, 4, 5. One, 2, 3, 4, 5. Right, there we go. This one is at -2. There's a point there, but I think I'll get a good enough idea just by halving this and then moving it down 1, 2, 3, 4, 5. Okay, so now I can take the graph and it should look something like this. Now, something to also recognize here is the horizontal asymptote. The horizontal asymptote, when you squish it, it moves in this way and this way, but at the same time it's already horizontal, it goes on forever, so squishing it isn't really going to do anything. So now we need to move it vertically down 5, so I'm going to go 1, 2, 3, 4, 5, which is going to put it right here, which I'm going to draw because I asked you to draw it, so it's only fair that I draw it. So there we go, which means that this line cannot cross that, can't even touch it. Okay, so there you go. The whole graph has now been shifted down. It's also been horizontally squished, which you can tell that's happened because it's now steeper than it was. All right, so let's go ahead and answer the questions down at the bottom. So the x-intercept of the original graph, there was none. Now because of the shift down, that's actually going to change that fact. Now, it's not at 1, because at 1, the value is 4, and so I can't say 1, but I can say something very close to 1, and so I'm just going to estimate that it's at 0.9, comma 0, right? The y value is 0, but the x value is probably about 0.9 there. Okay, the y-intercept for my original graph was 0, comma 1. It's been shifted down. Sorry, I should have said down 5 up here. So it's been moved down 5, which means it's now at 0, comma negative 4, which we can see. 1, 2, 3, 4. All right, let's look at the vertex. There is none because it is a exponential graph. The asymptote was at y equals 0. It's shifted down 5, which means that it is now at y equals negative 5, which you can see there in the graph. It's at the y equals negative 5. Now, domain and range. Domain for the original graph, if I start here in the middle, it does go to the left forever, and it does go to the right forever. Don't worry about the up and down yet. We're just looking at left and right, and that arrow means that it's going to keep on going and going and going to the right. So the domain originally was all real numbers. Now, if it was all real numbers and all you do is move it around and stretch it or squish it, then it will still be all real numbers. All right. The next one right here, the range. Well, if I start here and I go up, it does go up and up forever. But if I go down, does it continue to go down forever? The answer is no. It actually doesn't pass y equals 0. So it can't actually be 0, but obviously it can be anything up above that 0. So I can say that by saying that y has to be greater than 0. Now it has been shifted down 5, which means that the new range should be y is greater than negative 5. And if we go up and we look at the graph, you can see that, because it does continue to go up and up forever. But when you go down, it actually does not continue going down. It stops before it gets to negative 5. All right, so there you go. That's the next one. I'm going to go ahead and do the other one really quick. I'm not going to talk through it, though. I just want you to be able to check your answers. So here we go. I'm going to work out the rest of them, and then you can just check your answers with the key, which I will post on the website. Ciao.